In this video, we're going to show you how easy it is to do some psychometric calculations to determine your system performance. First thing we're going to do is take a look at a psychometric chart. This is a trained psychometric chart, and it's a representation of a pound of air at sea level. You have these lines that run all the way across. As you can see, they run all the way across, and these are the BTUs per pound, and they are along here and along here as well. Then you have your horizontal lines. These are your dry bulb temperature, the relative humidity lines, and they kind of curve up. The cubic feet per pound lines, and they go down and to the right. Dew point lines, and these lines go across. So dew point temperature. That same number as it goes down, that's the wet bulb temperature. As you can see, it says wet bulb temperature here. This is the saturation line. And we also have grains of moisture, and they go up vertically. And your vapor pressure also goes up vertically. And then the sensible heat ratio, and these lines go up this way. So what we're going to do is we're going to, let's zoom in just a little bit, and we're going to plot using ABT to show you how easy it is to do these calculations. So as you notice, if I put my tool on the left here and I'm at the 70-degree dry bulb temperature, that line doesn't go straight up. It actually shoots off to the left and up. So what we're going to do is we're going to take this line here, which would be 70, 71. It's actually 72. So we're going to say 72 at 60 degrees. We're going to take 72 at 60% relative humidity. So since this is at sea level, we're going to say 1 foot above sea level. We're going to give it a 72 at 60% relative humidity. And we've got the inlet button checked, so it'll apply it to the inlet. Now that number there, as we follow that up, it should represent 60, 61, 62, almost 63. 62.9 wet bulb, almost 63. And as we enter the rest of the data, our grains of moisture is 70.22. And as we come across, our dew point is 57.76. And lastly, our specific volume is 13.62. So if this is 13.6 and 13.7, this is about 13.62. That's correct. So now let's go ahead and take our next measurement, and let's just go straight across. And we'll say 90, 91, 92, and so this would be about 93 at about 30%. So let's say 93-degree dry bulb at 30% relative humidity. That should give us a wet bulb of 69.7. And as we come up here, we're about 69.7. That looks like that's right. And we'll go ahead and grains of moisture about 70.49. Our dew point is 57.87. And our specific volume is about 14.16. So 14.1 1.5 would be about there, so that's about 14.16. Now we'll go ahead and say this is 900 CFM, sensible only, and now we have our sensible heat in tons and in BTUs. So now let's do a second example. And in this example, let's say we're going to go reverse of what we just did here. And let's go ahead and say this is our inlet, but we're going to add some grains. So 93 at 90, 91, 92, 93 at 30%. And we're going to add, I don't know, let's go ahead and add about the removal of about 10 grains per pound. And let's go to $70, $71, $72. So let's say our outlet is 72 at about 50% for outlet. And as we go to our outlet, we already have our inlet and our outlet and our total load. And this is going to be removing grains, and it'll give us where our grains are. So at this point, it looks like our difference in grains, or the at 900 CFM, we're removing 0.81 or gallons per hour, and that would be about 6.78 pounds per hour in H2O. That's the removal. So the work being done, our sensible heat would be about 1.71 and about 0.61 latent. And 0.61 latent heat, and a total removal of 2.36 tons of cooling. Why do we need to know about psychrometrics? The study of thermodynamic properties of moisture and how it applies to every distribution system in our industry. First, we need to understand the equipment's performance as compared to design. Second, so we can recommend repairs and maintenance. And third, so we can ultimately advise the customer when to capital expense equipment that has reached its end of life. In fact, it's so simple to perform psychometric calculations. We can incorporate them into our standard troubleshooting and engineering protocols by using our sensible heat, latent heat, and total heat calculations, and our grains of moisture calculations. With ABT, these calculations can be completed within minutes with minimal data entry. Unique reports can be generated and given to those who need this information. Thanks for considering ABT. I hope you find this video helpful.